Yeah, so hello everyone. My name is Kushal and welcome back. So yesterday we had studied about the object-oriented programming concepts and how can we use them so that we can make more efficient programs and all that. So today we are going to study a new topic, that is modules and packages. So that is, we will need knowledge of classes for that. That is why that session was planned yesterday and this session is planned today. Okay. So without further ado, let's just dive straight into the topic. So what is a module? Okay. So now let me explain you with a very common example. So what is a module? Basically, let's say you are working on a software or a project. So it is not convenient at all that, let's say, okay, first let's consider that your project has 3 to 4 features. All right. So it's not at all convenient that you put all the 3 4 features in one Python file, right? That would become messy and unorganized and all that stuff. So instead of that, what we could do is we could organize the code into a much better simplified way so that we can, if there are any errors caused, then we can easily debug those errors as as we are dividing the code into many subparts or let's say many files. So if there is an error in one file, it will not affect the other file. This is one big advantage of using modules and packages. So, like if there is an error, let's say in a feature A, it will not affect any other feature of the program because it is in different file or module. So that is like an overview of what is a module. So in layman terms, if we put it, module is nothing but like a file in Python which is used to uh, which is used to divide the code in subparts to make them more efficient, and also we can use code reusability. Like if we want to use the same feature over and over again, we could just keep on using the module. Okay, we will learn later that how can we use modules in other files, but now first let's just understand the basics. What are modules? So as we create more and more classes, we need a way to organize them in such a way to make them available and easy to find. As I told that we will need them so that the code doesn't mess up and we can keep track of the code very easily and efficiently. Now these are very simple files and we can use, okay, what is a file? Okay, a file can consist of a class or it can also consist of multiple classes and functions, right? In Python, a function can also exist without a class. So we can also have some only like independent functions in a module. We can have a mix of class and functions in a module, and we can have multiple classes in a module. So these are like many permutation formations what we can have in a particular module. So I hope you get a clear understanding, a basic overview of what is module. And if you just consider real life scenario, right? So when we are studying in college and we have exams of the subject, so our subject syllabus, it is divided into 5 modules, right? It's not a single like syllabus that we have to study. I mean, we do study overnight, but still for the sake of the education management and all that, it's divided into 5 modules, right? So each module is, it is a basically a set of topics. Like if we combine many topics together which are related, it forms a module of our syllabus. So if you can relate that real life example, just like modules in Python, it would be more easy to understand. Okay, so moving on. Yeah, let's say as I told you about the software, let's consider another example. Like if we are building an e-commerce system and we are creating only a single file which contains all the classes, methods, and which are related to access the database and network and all that, then if then if the folders, I mean if the modules, necessary modules are in the same folder, those modules could use the database module to access the database, right? So if we have like a set of code which is used to access database and referring to database and everything related to database, we could put it in a single module, and all the other classes and modules, they could access that database module, and using that they could access the database. Okay. Now, this is just an arbitrary example. We don't need to go in depth, but this is just an example so I can explain you how we can, modules work and how we can import them into other modules. So let's just say if we have a point class, okay, and we have a file which can be interchangeably used as a module as we have discussed earlier, point.strings.py. Okay, it's a very weird name, but just bear with me. So this file contains this point class. Okay, so now if we create another file to include that class, we can follow this syntax: import and then point doc strings. So this point doc string is the module name. So in order to import any module, we can just use the keyword import and the module name in the file which we want to import. Like in later days when you guys will do NumPy for machine learning and all that, then you will see that we are import NumPy as NP. So that we are basically importing the numerical Python package in your program so that you can easily use functions. But that is for later discussion. So let's move on. So okay, now if we want to like create and let's now we discussed that there is a point class in the point doc strings module, right? So yesterday we learned how do we create an instance of the class. That was we used the class name and then parenthesis. All right. So here also, since this point class belongs to this point doc strings module, we will use the module name dot class name and then parenthesis to create an instance of this point class and assign that value to p1. Like it's just level of hierarchy. Like you saw right yesterday when we were trying to access functions using the class, we would use dot class name, class name dot function name, because the function belongs to the class. So similarly, this point class, it belongs to this module. So we will just use module name dot class name and parenthesis to create the instance of that particular class. I hope I'm clear. So basically, if this is another module in which we are importing this point of strings, we discussed the syntax, right? That if we want to import a module, how would we do that? So here we are creating an instance of the point of strings dot point class and storing it in p1, and we are creating another instance p2 and of the point class only. So these are just two instances of the point class which we are creating it, and we have to use the module name dot class name. That is the syntax for it. Now let's just consider that the point class which we had, it had a function. Okay, don't confuse class with function. Class, as we discussed earlier, class is a set of attributes and functions. You bundle the variables and the functions together to encapsulate it into a single unit called class. But this, we are talking about a method. So let's say we have a method like the point, one second, yeah, this point class, let's just say it has a method called move. Okay, don't worry what it does, just understand that it has this move method. So I'm sorry, I want to rectify myself. Earlier I told you that to access the methods we use the class name dot method name, but no, actually when we create the instance, we what we will do to access the function, we use the object or instance name dot the function name. Okay, so p1, we created this instance for this point class. So we will access this move function. Okay, and these are the parameters which we will give. Just don't just worry about what this move function does or any of this. This is just a demonstration type of thing, so that this concept can get clear. We are also calling the move function using the p2 instance. Okay, so these both of them are different instances, and obviously they will yield different results if we call move. And like, since we are if we had given same parameters, then it would be a possibility that these two would have given the same result. But obviously these two parameters are different, so the result also has to be different. So now we are calling. Okay, so just like this move method, imagine this point class also has attribute. Okay, that attribute is x and y, because see, any point it will have. See, it makes sense, right? It's point class. So a point will have x coordinate and y coordinate. We are not considering z coordinate over here. We are just considering x coordinate and y coordinate. And a class, this point class, it's pretty obvious that it will have this x and y attributes. Because if we consider a real point also, it has an x axis value and a y axis value, right? Those two axis, and then it forms a point in 2 dimensions. So we have this attribute p1.x and p1.y. So we are just calling this, not calling exactly, I would say, we are just accessing this attribute using the instance, just like we use the object dot function to access and call the function. We use the instance name dot. Okay guys, I am using the term object and instance interchangeably, so don't get confused, both of them mean the same thing. So we can use this instance name dot the attribute name to access the value of this. So we are just accessing the x and y attribute of this p1 instance, and we are just accessing the x and y attribute of this p2 instance. Okay, and we will just print it. I am not running this code because I have to fill in many details, and this code is just for demonstration. So now this thing, what is this? We are just in order to calculate a distance from, so this p1 dot calc distance p2, I have to implement it somewhere, and basically what it will do, it will calculate the distance between the p1 point and p2 point. P1 point will have two attributes x, y. So using the formula root over of x2 minus x1 square plus that formula plus y2 minus y1 square, and then root it, we will calculate the distance. So we are calculating the distance like p1 dot calc distance p2. So basically this is accepting another instance as a parameter, and this function belongs to the instance p1. It's a bit complicated to understand at first, but if you look at it closely, this p1 instance has a calc distance function, okay, which will take in parameter another point p2. That is why we created this second point. So now it must have made sense to you, right? What is this 2, 2, and what is this 6, 5? Why are we giving random numbers? Because this is basically x coordinate and y coordinate, and this is x coordinate and this is x coordinate and y coordinate for both the points. So now let's move on. So when we bring the point strings into the calling program, we say that point strings is now the part of the calling program's namespace. So what is namespace? Namespace is basically a list of methods and classes available to the current program. Okay, that's just a simple namespace. We will have the list of the methods and classes available to the current program. Now, if we want to just bring one specific class from a file, we simply say from point strings import point. So I told you, right, we can have a case where we can have multiple classes in a module or a file. So if we want to just import a single class and we just want to use its functionality there, we will just write the module from which we are importing and the class name or names. We will go that into later when we want to import multiple classes. So from module name, import class name. So we know that this point of strings has a class name point. So we are just importing this point class from point of doc strings module, and we have, and when we import this way, then there is no need to give point of strings dot point. Okay, we can directly give this point like we normally create an instance, right? One second. Yeah. So when we are not writing import point of strings, sorry, one second. I'll just charge my laptop. Yeah. So when we are just using the syntax import point of string, we have to use this module name dot class name and then parentheses to create an instance. But when we are importing point, when we are specifically telling that we want to import point from point of strings, the interpreter will understand and we do not need to give point of strings dot point in this case. If we just give the class name and parentheses like we regularly do to create instances, it will again work fine. Now there is another way which we can, import classes or anything from a module, that is from point of strings import point as pt. So um, it's basically saying that this pt will substitute this point. Okay, this pt will substitute this point, and again the module name remains the same, from point of strings import point as pt. As pt, basically if you guys have done c, so there it is, there no hash define and then pi and then 3.14. so what that does is it will just replace the value, right? So you can, and for well understanding, you can consider it's the same equivalent in Python. So basically when we are running this pt, it will replace internally into this point. Okay, that is just to make the word short and so that it can come handy. Okay, so now in order to declare instances, instead of point we will use pt, because we have imported point as pt. So interpreter will automatically understand and replace this pt as point and this parenthesis. So we will create the instance of point and store that instance in p1. Okay, so similarly we can, again, like I told, right, we will just use pt and then parentheses so the interpreter will understand, and we are again creating 2 points over here, the instances, different points, and again passing the same parameter using this xy coordinates, and again we are doing the same thing. First we are just trying to access this attribute of the instance, and then again we are trying to access this attribute using this instance, and then we will calculate the distance. It's the same principle. I've just wrote it twice so that you guys can again relate and understand like this. So basically this thing, okay, if we just use import point of string, then we have to write this in order to make an instance. And when we write import from point of strings import point as pt, then we just have to write these things. Okay, and it will work the same way as it did before. All right. So moving on now, as I told earlier that we can import multiple classes from one module, not just a single class. So how do we do that? We have learned, right, in order to import a single class from a module, we say from point of strings import point. But like let's say that point of strings had another class, let's say line. So if there is a module named point of strings dot py, okay, dot py is like Python file, and we told that we know that we can interchangeably use modules and files. So this point of strings py is a file and a module also. So from this file, if you want to, and a file can obviously it can contain multiple classes, right? It doesn't have the restriction to create a single class only. So if you want to, let's say, import two classes from this point of strings module, point and line, then how do we do it? So from point of string, we first write import, and then all the classes you want to import separated by comma. So here if you want to import two classes, let's say point and line, we will say from point of strings import point comma line. So in that way the Python language interpreter, it will understand that we want to import these two classes from this module. But you have seen a very general tendency. What people do is they will just use from the module name and then import star. So what is this star? This star is a kind of wildcard character. Okay. So what this wildcard character says is, it means that all the classes and all the functions which are present in that point of strings module, just import them. So basically the whole namespace, right? As the namespace is a list of all the functions and classes and all the other things in that module. So but I would suggest you guys not to do that, because see, if you don't need a class imported in another module, then why would you just import it anyway and block the memory, and the efficiency will reduce. So it's generally not a good practice. I know, like, people who are lazy like me, any day we would just use star. Who is gonna take the pain of writing each and every class's name when we can just use this wildcard? But we have to think about the computer as well, right? Okay, so if we move on now, basically, what is package? We have understood mostly the theory part of modules and all that. Okay, now what is a package? So as I explained earlier also, what is module? Module is basically a one file, and which can have as much as classes and functions and lists and all that, anything. So what is package? Now, when we have a very big project, let's say like it's a very big software, then like it's very difficult to organize all of the modules in a single folder, right? Like just imagine if we are creating a game. Okay, so in game, if there is one folder, so in that one folder, if you put all the files, like if you put the sound also, you will put the graphics also there, and then you will put the C sharp code also there, and then you will also put any other, like VFX, or all the, like how the physics will work and state machines and all that. So if you put all the files in that single folder, it would be a very big cluster. And generally, you are not going to work alone, right? You will work in a team. So you must like try to maximize the usability by which your teammates can read those files and folders. So keep those things organized. Python allows us to organize our modules into subfolders, which is called packages. Okay, so folder is the same thing, right? A folder, it may consist of many other folders, and those folders are called subfolders. Like in our computer, D drive is there. So when we open it, we will have many folders in it, movies and series and games and everything. And in that also, those subfolders are also folders, right? Movies, you will have many folders: English movie, Hindi movie, and in games also you have many games, action games, racing games, like that. So in Python, with those sub folders or folders in which there are many modules, it's a package. Okay. And what is the name of the package? The name of the package, simple. For simple convention, they have kept like this. The name of the package will be the name of the folder. Okay. So now how does a package keep itself organized? So you will have to see that, like, there is a module or a file called underscore underscore init.py in each subfolder, okay, which we wish to include in the project. So as you can see here, let's say this is a parent directory, and it contains two subfolders: main py drawing, and uh, actually main.py is a file, so it has this main.py file, and it has two other subfolders, drawing and maths. Okay, now this drawing is also a folder in itself, and it will contain init.py, point_call.py, and point_strings.py. And this maths will also have init.py and theorem.py. So this init.py, one thing I will give you word of caution: don't just confuse it with the init constructor that we studied yesterday in object-oriented programming. Like these both have the same ground-based purpose, that is initialize, but that is completely different, and this is completely different. Okay, so never confuse that init constructor with this underscore underscore init.py. This is a file, and that is a constructor, that is a function, and this is a complete file. Okay, so now let's just assume for once that is init.py is empty. Okay, just assume. Okay, I will tell you, like I will tell you afterwards what is this init and all that. Let's just forget about the init.py, let's just focus on importing. So basically, how do we import packages in Python? We have already seen, right, how do we import modules using the module from module name, import class name and names, and we will just write import module. All that things we have seen. But now when we come to package, how do we import the package? So basically there are two ways in which we can import the packages. Okay, one is using absolute imports and one is using relative imports. So what is the difference between these two? Okay, so an absolute import is an import when we fully specify the location of the class being imported. So now if we do this import drawing dot point call, okay, and yeah, drawing dot point call. So basically this is the whole, location of the class, right? This point call class, it is it is there in the drawing module. Okay, so no, sorry. This drawing is a package name and this point call is a module name. Okay. So like the hierarchy, if we follow, if when we create instance name dot function name, okay, when we want to access a function, instance name dot attribute name, when we want to access an attribute. Now one hierarchy level above, so module name dot class name when we want to create the instance. Okay, and then again one hierarchy other, import package name dot module name. Okay, and then if it just has a class, then dot class name, like that. So this is basically a package drawing, and this is a module point call, and then we just use this point call module name dot point class to create instance p1. Okay, right. So earlier we had seen the three ways in which we would import, using like using a numpy as np, like that, and then from module name import, like this. So here also we have three ways of doing it. So from drawing dot point call, again this is the package name dot module name, we will import point class. Okay, and then we will just create this instance p1 is point. Similarly, like we did for when we wanted to create, when we want to create an instance of a class in a module. Okay, no big deal. So again I will revise, package name dot module name, and then import the class which you want to use, and then to instantiate it, we will just use the class name and then parenthesis, and we will store it in p1. Now another way is from package import the module. Okay, it's like one hierarchy level above this. So this is module, and then import the class. So one hierarchy level above, from package import a module, and then like just we did like this, like when we import the module and we don't specify the class, then we have to use, right, module name dot class name parenthesis. So we will use this p point dot point call, and then the class name point, and instantiate the value in p1. So one second, again I will revise. So if we take the drawing package and then we will import this module name, okay, point call, and then we will use, and then to instantiate it, we will again use the module name dot class name parenthesis and store it in p1, because here we are not importing the class itself. So interpreter does not understand that which class you want to call. Okay, so that is why we will have to provide this module name dot class name. So I hope absolute import is clear. So now coming to relative import. Okay, so relative import specific the it will be specifies, sorry, my bad, it will specify the location of the classes to be imported relatively to the current package. So basically, if you guys have used the Linux or Ubuntu or command terminal, something like that, you will see that when we give one dot, it will represent the current directory, and if we give two dots, it will move one hierarchy level above and give us the this thing previous directory. So yeah, okay. So like in relative import, we will just say that when we want to import a package, so we will just use this dot, and then we will just use the package name. Okay, that will mean that we are just importing the package in this current directory. Okay, and now if we want to import this um, now if you want to import this package from a parent directory, which is not, see, basically what is this is, like in the module which we are importing the package, if the package is in the same folder, okay, same folder as the module, then we can just use one dot. But if it is one hierarchy level above, then we have to use two dots. Okay, so I will show one example to you guys when we will code. I'm thinking it's not clear to you guys, so I will just show an example a bit afterwards. What is PyPy? Okay, so PyPy is this pi is not 3.14. You don't think that it's 3.14. It's basically package index. The full form is Python package index. So till now we have learned, right, how to create our own modules and packages. So Python language also has its own system for keeping track of the packages, and it also creates packages for computation and all that. So that place is PyPy, and it is similar to Ruby gems in the Ruby world. PHP packages, cpan for Perl, and npm for Node.js. Those people who have done the learning of other languages, they could easily understand what I'm trying to say. So so far we have only used libraries that come internally with Python, right? So when we are writing any Python code, till now we have only imported the libraries which was only there in Python. So what if happens if you want to use third party library, if you want to import like NumPy, okay? In if it can be a possibility that NumPy is not directly installed in your system. So if you want to use that library, so how would you use that? So basically we will use the pip install command and then the package name to install these packages. I will show you how to do that, so don't worry. So like we have Anaconda, so in the Anaconda navigator command is there, no? There I will show you how to install pip and how you can just use the package. So pip is basically a tool, you can say, which we can use which you can use to download packages in our command line from the PyPy repository. Okay. Now there are packages already created for almost any use case you can think of. Like you just Google and then you do a bit of research and you will understand that which library in PyPy you can use for your purpose. So how do we download and install external packages using the pip command, command prompt and terminal? Okay, and the syntax is pip install and then the package name which we used to install. If it is not getting clear, guys, don't worry. I will show how to install any package using pip. Okay. Now, when we write this command, pip will install that package for us and we can use it in our program. Easy. Okay. So thank you. That was all the theory. And now, before getting on to coding, I would just show you once how the pip thing works and how we can use. Okay. So if you just write py and then we just write, so here, see, this is the Python package index. PyPy is a repository of software for the Python programming language. It will help us install software, and let's say I want to download a package, matrix package, okay, because its name is good. No other reason. Sorry, I have no relation to thermodynamics, but I like the name, so I'll just. So if I just click on it, see, here is the command given. How do we install this package? So if we just give the command pip install and then matrix package, so if we just give this command in Anaconda command prompt, it will install it for us, and then we can, when we are writing code in Python, if we import this package, it will not show any error. Okay, so if we just go to Anaconda prompt, so here I will not just copy paste, I will write, so pip install matrix package. Okay, yeah, pip install matrix package, yeah. So if I just click enter, it will wait for a few seconds and then it starts, see, it will start downloading. Okay, and see, after, my net is fast at home, so, and it's only 97 KB, so it's almost instantly installed. So it's showing successfully installed markdown 3.3.4 here matrix package 21.9.1. Okay, so I hope you now understand how to use pip and how you can install packages. Now I will demonstrate the use of modules and Python using Jupyter and code. So just give me a minute. Yeah, so hello guys again. So now we will try to code and try to understand how do we use modules and packages, and using this code I can better make you understand absolute and relative import. So don't worry, I will explain it to you. So we had discussed, right, the packages we import them into with absolute and relative. We will discuss that, but before that, let's just understand writing modules. So basically, how do you write a file in Jupyter notebooks, or like, this is the syntax. Okay, so percentage write file and then the file name dot py. Okay, so this is the, we will write a file using Jupyter notebooks, and here we have defined my function, which will take a number x and it will return the even number. Okay, and now we are creating a list one type of variable which is calling my function 11. Yeah, because see, it is going to return a list, right? When if we are going to return a number for every number in range x, the number, if n number mod 2 is 0, so we are returning a list of all the even numbers from 0 to this range x. Okay, so, and we are passing this value and we are trying to run this, and we will store the list in the list1 variable, and this is how we write file1.py. Like, this is the syntax. We write percentage then write file space file1.py, and now if we run it, see, it should, ideally it should say writing file1.py, but since I had already created file1.py, it's saying overwriting. So basically, if you already have file1.py created, so it will overwrite the file. Otherwise, it will say writing file1.py. Okay. Now you must have seen that there is no output coming. Okay. So because we haven't used any print statement over here, this has executed internally, but we can't see anything since it has been not printed. So again, if we want to write, okay, one more thing, this file and module can be used interchangeably. So we are writing a module file1.py. If you didn't understand when I say that file1.py is a file, you can also take it like file1.py. We are creating a module over here. Okay, a file, a module. Now here also we are creating another file2.py. Another module we are creating percentage write file and file2.py. Now see, now how, remember we had discussed that we will import the other module in this module by using the keyword import. Okay, so now this file1, okay, using this module file1, it has a attribute list1, right? So module1 dot attribute. Remember I told that the hierarchy module name dot class name dot append, but since here we don't have any class, so we can, without using class, we can directly access this list1 attribute from this file1 module name. And this list1, basically we are using this append function over here. Okay, here it is not printing anything because we are not running anything. Okay, we are just writing the whole program in the file. So that is why it is not printing anything. Okay, if we were just executing a normal, the basic difference is here we are writing the program in a file2.py. Okay, so I will show you. See, this is the file structure. Okay, this is the file structure, and here file1.py and file2.py was created. So this is due to this write file file2.py. Okay, so now if we want to run any file, so how will we run that file in Jupyter Notebook? So we use this not. If you guys have studied programming, this is the not symbol. So we use the not symbol and then we use the keyword Python. Okay. So this indicates that we want to run this file using the Python interpreter. Okay. So what this command will do, it will run this file2.py using the Python interpreter. So if we run this, yeah. So if we run this, we are getting the, okay, so we are here passing this value 12 over here, okay, and that is why here we are getting all the even numbers. Okay, we are getting here all the even numbers, but you must wonder that why are we getting 12 when I taught you that means the range here is till x and we have passed 11, but see, we have additionally appended the value 12 over here. That is why we are getting 0, 2, 4, 6, 8, 10, 12. Okay, so now if we use this, um, let's just run this. So now it will print it, right? Because we have already run this file and we are importing this file one. See, when we are writing the files, then if we give the print or anything, it will not work. Okay, but when we are normally importing a file and we will print it, so we are here printing this module dot attribute. Okay, so that is why it is printing all the numbers, and here it is not including 12 because I'm using file 1, and file 1 doesn't have any append or anything. Okay, okay, so as we have already seen that we use import to we use the keyword import to import modules and packages. Now you know, right, there is a math library in Python. So just taking that example, if we want to import a module, so basically how do we do that? We will use import math. and when we run it, it will import the math. And now if you want to use any inbuilt functions in the math library like math.ceil, what it will do is it will convert the decimal into the highest integer near, it will round it off to the highest near integer. So if we run this, we should get 3, and yes, we have got 3. So this is how we can import libraries in Python, and we can access um, we can access the inbuilt functions in Python. But I'm pretty confident that you guys have already seen all this before. Okay, so now what is this direct dir? So basically what is this is basically the module, okay, or the library which you give in this dir parenthesis. What it will do is it will show you the list of all the associated built-in methods with that module. So if I just run this, see, it says doc, loader, name, package, spec, acos, acos h, asine, and exponential, and pow is for power, pi is for 3.14, tan h, log to the base 10, log. So basically this dir that gives us a list of all the functions which we can use if you want to use this math library, okay. And second, this help. So how do we use this? We just give the we just give a specified function, okay, without the braces, without the not the braces, the parenthesis. We just give the function the module dot function name within the help, this keyword help, and then parenthesis. So if I just run this, it will just, it's type of a documentation. So if you don't know what does a built-in function do, you can always use this help, and then it will just see it is returning the ceiling of x as an integral. That is the smallest integer greater than x. So ceiling, so ceiling is the top of our building, right? So that is why ceiling means it will round it above. Like if it was floor, then it would round it to below, because floor is like low part of the house and ceiling is the high part. So it's like rounding off to the high integer, which is the most near to itself. Like even if it is 2.1, it will convert it to 3. Okay, and even if it is 2.9, it will convert into 3. Okay. So now moving on, now we have seen that how do we write modules. We just create the uh, file and then we will just import it, right? So now writing packages. So remember that time I told that let's just assume that this init.py file is empty. So basically why we give this init pack, why do we give this init module or file? This is basically to indicate Python that it has a directory and which contains a Python package, so it can be imported the same way a module can be imported. If we do not give this init file, the Python, it will not see, we have to give this init file, okay. Even if you leave that file completely blank, it's all right, but you have to give this init file whenever you are trying to make a package, because otherwise the Python language, it won't understand that what you are trying to do, it's a package and it can cause havoc. Like okay, I will discuss an example later if possible, but let's now, it's a very simple thing to understand that this init.py, it's compulsory when you are trying to create a package, okay. So now this is just an example. Import foo.bar, okay. So this foo is probably, it's a package, and this is module bar. So if we want to import a module bar from the package foo, so how do we do it? As we have discussed earlier also, package name dot um, module name. Okay, if I run it, it will give error. So yeah, as expected, because this is, it's written, this won't work, right? Because I'm just showing you this for demonstration purposes. There is no foo and no bar existing in computer, so obviously it will give error. And another way if you could do that is from foo import bar. Remember, like we could do in modules also when we were importing module names. So we would do that from module import class. Remember that point docs something. So from point docs import point, right? We would do that. So similarly, we can do that the same for packages also. Um, for packages also we would do that. So from package name, import the module name. Okay. So this is easy. So So you guys must have like seen, if you guys have already studied packages and modules, you guys must have seen a very common this statement. If underscore underscore name equals underscore underscore main. So what is it exactly? If you guys are wondering, I will just break it to you. So like whenever we are running a module in a package, okay, so this statement, it basically determines that whether this package is imported is I'm sorry, this module is imported in some any other module. I'll just give you an example and then you'll understand it better. So like in other language also you have seen that the main function is implicitly all the code at the top level, right? So basically, um, in Python, there is no such thing like main function that gets run automatically. This thing is different. So don't get confused with other languages where main function is there. This is the main. This is not the main function. This is the main module. Okay. So like I will try to explain this with an example. Okay. So whenever you are running a module directly, like you are not importing it in some another module, the name of that module, this name variable, it will always have the value as main. Okay, so that is why you are just using a simple if else to check whether the name attribute of the module, it is having the value main or not. So if it is having the value main, that means this module is being run directly. Otherwise, that it's being imported by something else. Okay. So yeah, so to demonstrate this name equal main thing, I will just try to demonstrate it using two modules. So here first I will write file 1.py as we do to write a file, and then we are defining a function. Function will print function in one because this is in one module. So and it will print top level in one because this is the top level. Okay. Now here we are checking if name equal main, then print 1.py is being run directly. Okay. Else print 1.py is being imported into another module. Okay. Now here we are not getting any output because we are writing the file over here. So similarly in second module we are writing 2.py and then we are doing import 1. Now we are doing print top level in 2.py. Okay, we are not creating any function over here like we did it in first module because we want to use the first module function over here, which we are calling it using the module name dot function name. Okay, we are calling that, and whatever output it will give, we will see that. Now again here we are checking that if name equal main, 2.py is being run directly as 2.py is being imported into another module. So if we run this, again we are getting overwriting 2.py because we have not executed it. So to execute it, you know that we use the not symbol and then Python and then the file name. So now it says top level in 1.py. Okay. So basically it's saying top level in 1.py because it anyways it will print the top level in 1.py and it is not printing function in 1.py because we are not calling this function in this. So now it's showing 1.py is being run directly because when we are just running the first module, it doesn't know that, like it doesn't see any of its itself, like it doesn't see itself getting imported in any other module. So that is why in this case name is equal to main. Okay, for this name equal to main, that is why it is showing 1.py is being run directly. Okay, now the moment I run 2.py, see what do we get. First we get top level in 2. So first we are importing 1. Okay, so when we import 1, we have no choice but we have to use this print statement, because whenever this one module will import or get used, then this function, not this function, this print statement will get called. So first we are getting top level in 1.py. Now it's saying 1.py is being imported into another module. Okay, so the moment it got imported, this else condition got met, because this one, it got loaded into its namespace, and namespace is bundle of its class and functions and variables. So the moment we do this import one, it will, the name will not be equal to main. Okay, and after this import statement, as it will run from top to bottom, this time the else condition will meet. See, when we first ran the 1.py, it showed that top level is 1, and when we are importing it, it will again execute this file, right? So when we are printing, because that is why we are getting this print top level in 1 page, and the moment it has got, imported and got loaded into this namespace, that this name variable will not have the value main, and that is why it will print 1.py is being imported into another module. Okay, now it will run top level in 2.py. So now it will sequentially run the statements. So top level in 2.py will print, and then we are calling this function of 1. So now it should print function in 1.py. So here it is, function in 1.py it is printing. And since this second module we are not importing anywhere, so the name is equal to main, and hence 2.py is being run directly. So basically, if I summarize, what happens is, this name variable equal to main, we basically check that if it is the main module in the package, okay, or maybe in a collection of modules, is it the main module? If it is not getting imported to any other module, then in that case it is the main module, and that means it is being run directly, otherwise it is being imported into another module. So I hope this concept was clear. Okay, so coming to our last topic, we discussed that we can import packages using two methods, right? One was absolute and one was relative. So absolute was when we give the complete location of the file. I will explain and demonstrate using this example. So let's say we have this hierarchy, okay, a tree hierarchy. So we have the, okay, you must have noticed this init.py over here, because I told you, right, in packages we have to give this init.py, otherwise a Python won't understand that that we have to treat it as a package. So this init.py thing and the start.py thing, so these two are basically files, and empty, non-empty, just forget about that. These two are just files, these are not folders. And remember, a package can have many folders. So this mod A is a package, module A basically, and this module B is also a folder. Just consider it as a collection of files and modules. Okay, so this module A is a collection of these two files, and this module B is a collection of these two files. And since both of them are packaged, so we have to give again init py init.py in it. Okay, both of these files will be here, and it contains its own file 1 and file A and file B. Okay, now if we want to import this package, so how would we import this package? We would use from this package name, from mod A, import file A. Okay, Now when we are doing this, if we are in if we are writing code in start.py, okay, if we are, let's say, if we are in this um, let's say we are currently in this file, okay. So when we are in this file and we want to import this file a.py, so in this case we have to give absolute file path of that. And how do we access this? So the hierarchy is mod a is a folder, and in that there is a file a.py. So mod a, from mod a import file a, okay, because this is level 2. It's just consider it like a tree. These are all level 1, and this is like the children of this level 1, like subfolders or sub files, you can say in easy terms. And similarly for B package, what we are doing is from module, not this just mod, okay, from mod B import file B, okay. Now if we don't want to do like this, like if we want to import a class, okay, let's just say this, I would say, just let's just say this file consists a class simple, okay. So how would we import that class? So we will use mod a dot file a, which is the package name dot this thing module name, and we will import the class name. And for, okay, this is the same, it's just repeated, so no worries. And file b dot simple. So basically this is, we are trying to instantiate it, okay. We are just trying to instantiate here, use and instantiate. Basically we are not storing it in an instance, so we are instantiating it, but the thing is, see, this is b simple, so we are just trying to use a function, okay. We are just trying to use a function b simple, a function b simple inside the module file b dot file, okay. So here we are just trying to use a function b simple, which is inside the module b dot file. So that is why module name dot function name, okay. Now we come to relative. So what is relative? Okay, so basically relative is like, relative velocity also, right? Like one thing will be dependent on another. So here also we have the consider the same hierarchy, okay. This is module a, like the package, and it has init and file a. And this is mod b, and it has package, file b, and init, and inside it has another mod a, okay. So this is mod a, and this is also mod a, right? So but see, these both are different subfolders, so there is no problem. And it inside it has file c dot file, and init, this init file is compulsory, as we discussed. So if we are like um, if we are basically, if we want to import this function b, okay, so let's say this file b, let's say it has a class function b, or okay, let's say it has a class function b, and um, we want to import that in file C. So currently we are in this file. So basically this file is in the parent directory, right? Is in the parent directory. So that is why it's the relative way to import is dot dot, because dot dot indicates the parent directory. So the parent directory is file B, and we will import the function B, which is from here, which is the class from here. So this dot dot is because of the parent directory. Okay. Now let's say if I had let's say if I had some file in the same level currently, like it would be in the same level. Okay. Like then let's just say file underscore d dot file. So to do that, we would not need double dots because it's not the parent directory, it's in the current directory. Basically, this file D also belongs to this mod A directory, folder or package, anything you say. So basically, we will do from dot file D, file D import um, a class in file D. Okay. So basically, this is when relative layouts, sorry, not relative layouts. This is when relative, import comes handy. So if the file is in the current directory in which we want to import it, then we just use a single dot. And if the file is in the another folder, like it's in the parent directory, then we use this double dots. Okay. And if it is some other random directory, then we have to use absolute import, because in that case it's not relative, right? So this was just an overview of relative and absolute imports. I hope I made clear. So this is the basics of modules and packages. There is, like, you can go on more advanced level if you want to. And I hope you enjoyed the session, and I hope whatever I taught you was clear. If you have any doubts, you can just ask us when the sessions will be there. And yeah, with that, bye and have a nice day. Thank you.